Hi everyone, welcome back. So let's look at another example showing types of proofs. This question is, prove by exhaustion that the product of three consecutive integers is even, right? So consecutive integers is something like this. So let's say 1, 2, 3, 4, 5, 6, 7, 8, 9 and so on and so forth. So three consecutive integers mean maybe you can take these three are three consecutive integers, which mean 1 times 2, 2, 2 times 3, 6, so is correct. So if you take this is also three consecutive integers. What is the multiplication of these three? 2 times 3, 6, 6 times 4, 24. So that is an even number. So how can we prove this one? Prove this one is, let's say, so we need to denote these three consecutive numbers as an algebraic expression. Let's denote the first integer as n. If the first one is n, the next integer would be n plus 1, right? And the next one would be n plus 2. So these are the three consecutive integers, but n could be odd number or n could be even number. So we can start from odd number then even number then odd number, or if n is even then we are starting with even number, odd number, even number. So let's expand this one. So if we expand this, the last two brackets, it would be n squared plus 3n plus 2, and if you expand it, everything is would be n cubed plus 3n squared plus 2n. So this is the expansion of three consecutive integers. Now the question is, this one, the final expression, is it even number regardless of whether n is an odd or n is an even number, right? So let's see how we can prove this n cubed plus 3n squared plus 2n is always an even number regardless of whether n is an odd or even number. So let's say if n is even, right, n cube is even, okay, because if you multiply an even number 3 times, it's always even. And what about 3n squared? 3n squared, n squared is even again, right? If n is even, n squared is even. So if you multiply even number by odd number, the output is always even number. And what about the third term, 2n? n is even and you are multiplying even by another even number, this is going to be even. So when n is even, this statement is even. So they have done the proof for the first half. Okay, now we need to show the same statement is even when the n is odd, right? So if n is odd, n cube would be odd. You can check, like if it's n is 3 times 3 9, 9 times 3 27 is odd number. So n cube is odd number. And what about 3n squared? So if n is odd, n squared will be odd as well. So if n is odd, n squared is odd, and n squared, so multiplying odd number by another odd number again. However, if you look at them together, like n cubed plus 3n squared, this is odd number, we have proved it. This is odd number, we have proved it. But if you add two odd numbers, that would be an even number. So if you look at this part, this is adding both of them will give you an even number, and the last part is 2n. This will always be even number because you are multiplying by 2, so this will be an even number. So we have shown that this part is even and you're adding with another even, so the final outcome is also even. So n cubed plus 3n squared plus 2n is even. So now we have shown that this statement is even regardless of whether n is an even number or n is an odd number. That concludes the proof. Thank you so much for watching this video, but we are going to do 2 more questions, so please check out the other videos to learn more about types of proofs. Bye for now.